The universe is expanding, but where is it taking us? And how will it all end? Imagine nothingness, a void, then a flash. Not just any flash, but the birth of everything we know, everything that has ever existed. Scientists believe this is how our universe began, the Big Bang. They saw not just distant stars, but entire galaxies, billions of stars collected into huge spiral islands. And the deeper they looked, the stranger things became. It was like watching a train that appears to be standing still suddenly accelerate to an incredible speed. Or imagine standing on the shore, watching all the ships on the horizon sail away. And the farther away a ship is, the faster it sails. It was counterintuitive, defying everything we knew, all logic. If the light is redshifted by moving away, then these galaxies aren't stationary. They're moving. And not just moving, but actively flying away from us, from Earth, from each other. It was the first truly revolutionary discovery that began to shatter the old, static model of the universe. The world that seemed so unshakable was suddenly in rapid motion. And this movement was just the beginning. Enter Edwin Hubble, a name now known to anyone who's ever wondered about space. Picture the early 20th century. Astronomers looked at the sky and saw these strange, fuzzy patches. They called them nebulae. No one really understood what they were. Some thought they were just gas clouds inside our own Milky Way galaxy. Others suspected they were entire island universes, like our own, but incredibly distant. It was one of the biggest debates in astronomy at the time. Then, Hubble got an incredible tool, the 100-inch Hooker Telescope at the Mount Wilson Observatory. It was the most powerful time machine in the world at the time, allowing him to see farther than ever before. Hubble began methodically studying these nebulae, aiming to discover whether they were our neighbors or strangers from another universe. And he found the key. Within these nebulae, he discovered stars that pulsated with a certain rhythm called Cepheid variables. These stars are like cosmic beacons. The brighter a Cepheid, the longer its pulsation period. So, knowing how bright it should be and how dim it appears to us, you can accurately calculate its distance. It was a breakthrough. Hubble began applying this method to the Andromeda Nebula, then just one of the brightest nebulae. And then something amazing happened. The calculations showed that Andromeda wasn't just far away, but incredibly far, beyond our galaxy. It wasn't a cloud of gas, but a huge independent galaxy, like the Milky Way, but millions of light years away. It was the first clear signal. The universe is far bigger than we thought. It's full of billions of these island universes. But that was just the start. Remember Redshift, which showed that galaxies are moving? Hubble combined his distance data with velocity measurements made by another astronomer, Vesto Slipher. And that's how one of the most fundamental discoveries in the history of science was born. Hubble noticed a clear pattern. The farther away a galaxy was, the faster it was moving away from us. This wasn't a coincidence. It was a law, Hubble's law, as it's now known. Imagine blowing up a balloon with dots drawn on it. As the balloon expands, all the dots move away from each other. And the farther apart the dots are, the faster they seem to separate. Or another example. Raisins in bread dough. No, every point in the universe sees all the others receding from it. This was a shock, a revolution in thinking. We no longer lived in a stationary cosmos. We found ourselves at the heart of a grand, endless motion. This discovery changed everything, from our understanding of the universe's origin to our place in it. We aren't just observers. We're part of this incredible, ever-expanding dance. Nobody will tell you that the universe isn't just expanding, it's accelerating. This is the mystery that's currently puzzling the best minds on the planet. In the late 1990s, two independent groups of astronomers were conducting research. Their goal was to measure how much gravity was slowing down the universe's expansion. It's logical. The more mass, the stronger the attraction, the slower everything should be flying apart, right? They used very bright cosmic beacons, Type 1a supernovae. These are special stars that explode with almost identical brightness. Knowing their true brightness and how dim they appear to us, we can accurately determine their distance. It was a brilliant way to look into the distant past of the universe. But what they discovered wasn't just unexpected. It was a cosmic knockout. Galaxies at enormous distances were farther away than they should have been if expansion was slowing down. This meant only one thing. The universe isn't slowing down. It's actually accelerating. But we see its effect. It makes up about 68% of all the mass and energy in the universe. Imagine, almost 70% of everything that exists is something we know nothing about. There are several ideas about what it might be. Maybe it's an unknown form of energy inherent in empty space itself. The vacuum, which we consider empty, is actually seething with energy. Or perhaps it's a completely new, unknown fundamental field that permeates the entire cosmos. Whatever it is, this dark energy acts like a kind of anti-gravity. It doesn't attract, it repels. It pushes galaxies apart, increasing the space between them, and it's doing so with increasing force. It's not just an academic puzzle. Dark energy changes everything. It determines the future of our universe. If it continues to accelerate expansion, our cosmic home faces a very unusual and possibly frightening end. We're moving towards an unpredictable end, which depends on the nature of this elusive but almighty force. And the more we learn, the more questions arise. Imagine the stars starting to fade one day. Or, conversely, everything around us flying apart at insane speed. Our cosmic end won't be boring. We already know the universe isn't just expanding, it's doing so at an accelerating rate. And that elusive dark energy is responsible. But what does this mean for our future? Where is it taking us? Scientists, like real detectives, have sketched out several doomsday scenarios. And believe me, they're far bigger than any Hollywood blockbuster. The first, and perhaps most likely scenario, if dark energy continues its work, is the so-called Big Freeze, or heat death, of the universe. Imagine, the universe continues to expand, becoming bigger and bigger. Galaxies are flying apart so quickly that we'll stop seeing the light from our neighbors. It will be a slow, inevitable, but incredibly grand end. A whimper, not a bang. But there's another, far more dramatic and frightening scenario, the Big Rip. It's possible if dark energy turns out to be not just a constant force, but something that gets stronger over time. If its density increases, It will begin to tear apart not just galaxies. First, it will overcome the gravity that holds together clusters of galaxies. Then, the galaxies themselves. Stars will be torn from their orbits. Planets will be ripped from their stars. And that's just the beginning. If dark energy becomes powerful enough, it will tear apart even atoms. Electrons will detach from nuclei. Nuclei will break down into elementary particles. All matter, everything we know, will be literally ripped into the tiniest pieces. The universe will turn into a soup of scattered particles that will fly apart at speeds exceeding the speed of light. This won't just be an end, but the complete annihilation of the very structure of existence, instantly and irreversibly. What about the Big Crunch? This is a classic scenario that was long considered the most likely. Imagine the expansion of the universe as a ball thrown upward. At some point, it must slow down, stop, and start falling back. It's the same with the universe. Gravity should eventually overcome dark energy, stop the expansion, and start squeezing everything back together. Galaxies would begin to converge, then merge. The temperature would rise until everything collapsed back into one unimaginably hot and dense point, an anti-Big Bang. But with the discovery of accelerated expansion, this scenario seems less and less likely. Dark energy seems too strong for gravity to overcome. So, what end awaits our universe? The Big Freeze? The Big Rip? Or something else we don't even know about yet? The answer depends directly on the nature of dark energy. We're on the verge of the greatest discoveries, which may shed light on this mystery. And until we solve it, the future of the universe remains unpredictable. But one thing is clear: our cosmic home isn't eternal. And this makes us think about our place in this grand, ever-changing dance of existence. Imagine every second, the space between galaxies expands by thousands of kilometers, carrying us away. In this race, we're just a tiny speck in one of 2 trillion galaxies, and it changes everything for our understanding of the future. We've discussed the Big Bang, expansion, acceleration, and possible scenarios for the end of the universe. It all seems incredibly vast, almost abstract. But behind all those trillions of galaxies and billions of years lies the main question. What does it all mean for us, for our little planet, for our short but rich lives? Imagine yourself in a vast ocean. You're sailing in a small boat, surrounded by endless water that's constantly rushing somewhere. That's how we feel in this expanding universe. We're a grain of sand on a grain of sand in one of hundreds of billions of galaxies, which in turn are flying apart. Against the backdrop of these cosmic dramas, our life seems ridiculously fleeting and insignificant. But that's where the paradox lies. We, these small creatures, have been able to comprehend these grandiose processes. We invented telescopes that look billions of light years away. We've developed theories that explain the birth and possible death of the cosmos. It's amazing. Our ability to ask such questions and seek answers is what makes us truly unique. We aren't just passive passengers on this cosmic ship. We're its curious explorers. It's this understanding that drives us. If the universe is doomed to the Big Freeze, we have little time to leave our mark. If we face the Big Rip, we must understand its nature to prepare. This knowledge doesn't frighten, it inspires. It makes us value every moment, every opportunity for discovery, for creativity. Think about the future. If our Milky Way galaxy ever collides with Andromeda, and it will happen billions of years from now, long before the end of the universe, it will be a cosmic spectacle. Stars won't collide, but their orbits will change. But even if we survive that, what will happen next when all the other galaxies disappear over the horizon? When all that's left around us is an endless black void? This makes us think about colonizing other planets, about searching for extraterrestrial life. If we aren't alone, then perhaps other civilizations are also facing the same fundamental questions. Maybe they've already found answers, or are searching for them as desperately as we are. Our place in this dance is to be observers, explorers, perhaps even creators of our own, albeit small, but significant future. We aren't just moving somewhere, we're moving with the universe itself, and that makes our story unique. We've traced the path of the universe, from the Big Bang to its possible end. But you know what's most striking? The more we learn, the deeper the chasm of our ignorance becomes, and the grander the mysteries that await their hour. We see its effect, but we don't know what it is. Is it simply a property of space, or some new unknown particle? If we understand its nature, we can accurately predict the fate of the universe. Will it be the Big Freeze, the Big Rip, or maybe something completely different that hasn't even occurred to us? It's like trying to predict the ending of a book, knowing only half the plot. Let's go further. Dark matter. Yes, the one that makes up about 27% of the universe. We don't see it either. And finally, the most important question: why does the universe exist at all? Why are the laws of physics exactly as they are? Why did they allow the appearance of stars, planets, life, and ourselves capable of asking these questions? Is it a coincidence? Or is there some deep yet incomprehensible meaning to it? Each new generation of telescopes, each experiment on Earth, each new theory is a step towards unraveling the mystery. We're building new observatories, sending probes to distant planets, trying to capture elusive particles. We're looking for answers, and every time we find one answer, it opens up 10 new questions before us. But that's the beauty of it all. It's an endless journey of knowledge that will never end, and we're part of it. We've only just begun our journey through the mysteries of the universe. If you've enjoyed learning where we're headed and what mysteries await us, don't miss our new stories. Subscribe to the Epoch Echoes channel to explore the cosmos with us, and give this video a like if it made you think.